So in this video what we're going to have do is have a look at something called back titrations. Back titration is something that may cause students a little bit more anxiety because there's multiple steps, so not quite as straightforward as a regular titration. In these titrations what we're doing is trying to analyse things that we don't know enough information about to directly calculate, because they perhaps do not react directly in a titration. So in this section we're going to look at things that are not soluble in water but will react with acids. So we couldn't titrate them directly because we can't put them into solution and use them in a titration, but we can get them to react with an acid. So an example might be something like a limestone rock. We couldn't put it into our conical flask or our burette, but we could react it with acid and see what we're left with. So we're going to use a lot of acid, an extra amount of acid, we're going to call that excess acid, and then we're going to titrate what's left. So a little analogy to help us get our head around what we're doing here. So here's our little analogy. Imagine you've got £50 and you go into the first shop in the street and you come out having bought 2 Woody dolls. You couldn't tell me how much it cost to buy a Woody doll. So what you do is you go into another shop, we find something out in the second shop that we see the sale price. So maybe you've sent your child out, they've come back with 2 Woodies and 3 buzzers, and you knew that buzz cost £8.50, they've come home with no change from £50. Can you figure out how much Woody cost in the first shop? So how would you approach this problem? You would look at what you spent in the second shop because you knew the price of buzz, you knew what was going on when the excess acid reacted in the titration, and you would use it to work out how much reacted in the first part of the experiment, the bit that you couldn't do because you didn't have the information. So how would you work this problem out? You would find out what 3 buzzers cost at £8.50 each, so you would add that up, £25.50. And then you'd say, well, I started with £50, I sent them out with £50, they spent £25.50 on buzz, that means they must have spent £24.50 on Woody, and they got 2 Woodies, so each Woody must have cost £12.25. And this is the sort of process that you'll be using in a back titration, it's just that everything's going to be chemicals. So how would we do that? So here's our problem. We've got 2 indigestion tablets, so 2 Rennie tablets, something like that, and we don't know how much of that indigestion tablet is actually the chemical magnesium hydroxide. Part of it's magnesium hydroxide. They were put into here, so we've got 2 tablets. They were put into 25 centimetres cubed of 1 mole per decimetre cubed HCl. So this 25 centimetres cubed of 1 mole per decimetre cubed HCl is our £50. It's our too much stuff, our too much money, and our 2 tablets, our Woodies. 25 centimetres cubed of 1 mole of hydrochloric acid. Now that is way too much to buy, to spend on 2 tablets. It's an excess. So we're going to have some hydrochloric acid left over. Okay, so we're going to titrate what is left over. So they're going to react, and we're going to titrate what is left over with sodium hydroxide, and it's 17.4 centimetres cubed of NaOH, and it's told us that the concentration is 0.750 moles per decimetre cubed. So this is our second part. This is where we know what we're spending in the second part of our experiment. So we've got some sodium hydroxide here. Okay. So what happens at first is we've gone into our first shop with our lots of money, our 25 centimetres cubed of HCl. So this is at the start. What was our £50? How much did we have? So let's work it out. Okay, so 25 centimetres cubed into decimetres cubed. How much HCl did we put in at the very start? So see if you can work that out on your calculator. If not, 0.025. So that's like our excess, that's our big amount at the beginning. So that's 0.025 moles of HCl at the start. They are going to react with our 2 tablets, but we just don't know how much we're spending on the 2 tablets. We don't know how much the 2 woodies cost in the first shop yet. So what we don't know is what's going on in that flask. What we do know is what reacted in the titration. So what we can do is work out how many moles of NaOH are in the titration by doing volume times concentration for that. So 17.4 times 10 to the minus 3 times 0.750. So you could work out that on your calculator. 0.01305. So that's working out how much we spent in our second shop, essentially. That's our number of moles of NaOH in our titration. What we can do from that is work out how much HCl was still in this flask. This is like the taking away part. How much HCl was still in here when we did our experiment. So this reacts with HCl in this flask. But it doesn't react with all of this HCl that we put in, because remember we spent some in the first shot. We spent some on the 2 tablets. So let's use the ratio. So we're going to need to think, what's our equation for our reaction between NaOH? How do NaOH and HCl react? Well, they react 1 to 1. So if I had 0.01305 moles of NaOH, then I must have had 0.01305 moles of HCl in my titration. So now I know that I went into the first experiment with 0.025, and after I'd spent some on the 2 tablets, I was left with 0.01305. So number of moles of HCl used to react the tablets must be the difference between these 2 numbers. That's 0.01195. Now the question isn't how much HCl was used, it's not just the money. We need to go back and work out therefore the mass of magnesium hydroxides. So what we need now is another balanced equation. How does magnesium hydroxide react with hydrochloric acid to make a salt and water? And if you balance that equation, you'll need a 2 there and a 2 there. So now our ratio is 1 to 2. So we can work out the number of moles of magnesium hydroxide would be 0.01195 divided by 2. If you work that out, you get 5.975 times 10 to the minus 3. That's the number of moles of magnesium hydroxide in 2 tablets. What's the mass of magnesium hydroxide? Well, mass is Mr. moles, so add up the MR of magnesium hydroxide. You get 58.3. And multiply it by our number of moles. And you should have got 0.348 grams. That's in 2 tablets. So the mass of 1 tablet equals half of that, which is 0.174 grams. But the question did ask for it in milligrams. So just to keep us on our toes, we need to convert that into milligrams. each tablet contains 174 milligrams of magnesium hydroxide. So quite long, quite complicated, but break it down. So remember what we did was we worked out how much money we started with, which was our hydrochloric acid at the start. We worked out how much sodium hydroxide was used, and therefore how much hydrochloric acid, how much of our money was used. The difference must have been how much we spent on the tablets at the beginning. We then used that amount to work out how much magnesium hydroxide we had at the beginning. We worked out the mass and we divided it by 2 because there were 2 tablets.